So there are two types of logarithms that you will find on a calculator. You will find a common log, which is a base 10 log, and that just says log. You also find what's called the natural log, which is abbreviated ln, okay? Now, that ln is just a shortcut for writing log base e. So you can write log base e or you can write ln. They are both the exact same thing. This just gives us that shortcut notation. To make your ln look more as if it is a thing, try to write it in cursive. If you write just L and then N, it almost looks like one N, and so it can get a little confusing as you go through the process. So I would try to write it in cursive as you go through the process. Again, that's not super necessary. It's just a suggestion, okay? The E we're talking about is that 2.71828 figure. They've taken it out a few more times than we see before. You can type in imath ln, or you can do the log underscore e. E, you can just type into imath. It understands when it sees e, just like pi is 3.14. It'll understand that e is that 2.71828. You are going to have to know how to go back and forth between these two things. Just like we need to go back and forth between any sort of thing, you need to know that this means that our base is an e, the number will equal e to a power of p. The answer to any logarithm, whether it's a log base 4, a log base e, a log base 10, they all have an answer that is representing a power, okay? So that being said, let's scroll to problem number 6. So for problem number 6, it says convert each of the following to exponential form and evaluate or estimate the value of the unknown. Check your answers using your calculator. Well, I'll be your calculator, but let me talk you through this process, okay? Now we're going to convert a into its logarithmic form. Now remember, if you don't see it, you have to know that technically there's a little 10 there. The base is 10. So if we look at this problem, this is what you want to know. The base is 10. The power is x. The number I'm comparing is 1 over 100. Okay, let me say that again. The base is 10. The power is x. The number we're looking or concerned with is 1 over 100. So let's use that. So 1 over 100, that number is 10 to a power of x. Okay, now what do we do from there? Well, from there, I would think about how is the number 1 over 100 related to 10? Well, 100 is 10 squared. And if we want to flip it, that becomes 10 to the negative 2. Let me say that again. 10 squared gives us 100, but if we want to flip it, we have to make that power negative. And so x would have to equal, the power I'm searching for is negative 2. Now, how could you check your work? Well, you could put into your calculator 10 to the negative 2 power. You should get 1 over 100. You can go the opposite way. This is one where we have a log button in our calculator. If you put into your calculators now, if you want to use a calculator, the button that actually says log, if you put log of the fraction 1 over 100, you should get negative 2. So this is one where a calculator is optional. You can use a calculator for these. The red calculators in the back do have a log button and a natural log button. So technically B we can do on a calculator. It will give us, you can put ln of e squared. But let's kind of show you how it works. The number we're concerned about is 2. The base, although we don't see it, is an e. So this is e to the k. What do we see? Well, 2 has to equal k. Okay. Now, let's say we wanted to check that into a calculator. On this calculator, if you hit ln, then you hit second ln, the e will pop up, put a 2 in there, and then it's going to cancel. Now, why does it cancel like that? When these two are sitting next to each other like that, since a natural log and an e are inverses of one another, the answer will just be the power. But this is how you can prove it to yourself or show it. Okay. Now, for C, we must use a calculator. The reason we must use a calculator is because we don't have a e sitting there that we can relate it to, okay? Technically, you know, we could say that 7 is e to the t power. We could say that 7 is e to the t power. That doesn't get us anywhere. If you use a calculator, the natural log of 7 is something. It's approximately, that is a really ugly approximately, it's approximately 1.946. So that is one where a calculator is really just the way to go, okay? That is just the way to go for number C. There's nothing else we can do, okay? Now, D is a base 10. Logs originally were created for kind of an accounting purposes, and it was so that back in the day, think if you were an accountant and you're writing out all these numbers by hand in a big log book. You are writing those numbers out, and if you want to shortcut the process, this is really great because the answer is just going to be 3 because we have 3 zeros sitting there. It's a base 10 log. But let me kind of backtrack a little bit. This would be 1,000 is what power of 10? Well, 1,000 is 10 to the third, and that's why the answer is 3. The power I want on a 10 to get 1,000 is 3. Remember, the answer to a logarithm is a power, okay? The answer to a logarithm is a power. But technically, you could try right now on your calculator. If you just use the log button, log of 1,000, hit equals, it'll tell you 3. So, but it's really important that we know why it's 3 and how that came about, okay? So that is a little bit about some of the things you can use on a calculator. Remember, a common log is a log base 10. This sentence right here, you might want to highlight. A log of x is just a base 10. A natural log of x is just a log base e. So just remember that the buttons on your calculator are exclusively for base 10 and natural log base e. Right now, eventually I'll give you a formula, but right now we don't know a formula that we can use that calculator. We can't use it like for if it was a log base 2 or log base 7 or log base 5. It doesn't work, okay? So just be careful as you go through this process. Now, this table right here is super important. We are going to use these formulas to condense logarithms and expand them, and eventually tomorrow when we talk about equations. So it is important that we know properties 1, 2, and 3. So I want to go through what these properties tell us, okay? The first property here says that if you have trapped in the logarithm the multiplication of 2 things, it can be the multiplication of any 2 things. We are allowed to split it up in their individual logarithms as long as we add. Now, why does that multiplication inside become an addition outside? Well, it's because of our rules of powers. The answer to a logarithm is a power. If the bases are alike and we're multiplying, we add the exponents. So it's almost like we've added the exponents. We've added the powers. So we know the rule for exponents is if the bases are alike and we're dividing, we subtract the exponents. So then it makes sense that it's the log of the top minus the log of the bottom. That's how we would expand that one. And if we have a power to C, if the power is to a power, we multiply. So see how that C multiplies down in front. So these 3 powers, or these 3 power rules, log rules, follow directly from the rules of powers. Multiplication becomes a separate addition. Division becomes a separated subtraction. And then a power to a power, that power can drop down in front. So you're going to have these powers or these rules memorized. It is super important that we have them memorized and we know how to use them. So I want to show you how to do that. If you could please scroll down now to problem number 9. Now, number 9 says that we are going to use the properties to rewrite each expression, okay? This section here I believe. Yeah. This section here, some books will call this condensing because we're trying to condense multiple logarithms into one thing, okay? So if we want to condense an addition, so if we have two logarithms of the same base, same type of logarithms, and we do an addition, we can condense them together. They're going to become a multiplication. So this is going to be the natural log of x times x, or the natural log of x squared, okay? Now, but there's another power rule that says if you end up inside with a power, drop that power down in front. So we end up with the simplified version as much as possible as 2 natural log of x. Now in part B, that's just going to be the log base 3. That continues along with the process. We can combine that addition by putting it as a multiplication inside one logarithm. We can condense it into one logarithm as long as we multiply. So that's just the log base 3 of the number 10. Now, I don't know how 10 is related to 3, so that's why you're just going to leave it. You can't do anything special to it. Now, I'm going to show you 2 different ways to do C, okay? Because these 2 numbers are related to the number 4, let's convert them first, okay? So maybe you look at it and go, oh, what power do I put on a 4 to get 16? 2. What power do I put on a 4 to keep it 4? 1. The answer is 1. So if that's the route you take, go for it, okay? Now, let's try it a slightly different way. 2 logarithms that are subtracted can be combined if inside we divide. So that would be the log base 4 of the fraction 16 divided by 4. The positive thing is your numerator. The thing you're subtracting is your denominator. Okay. 16 divided by 4 is actually 4. What number do I put on a 4 to keep it a 4? 1. So if you decided to change it first, you'll get the answer of 1. If you decided to use one of our condensing rules and then get the power, you're still going to get 1. So there are multiple ways to do these problems. So it's a matter of how you want to look at them. D, there is no way further we can go with that problem because the bases are different. Since the bases are different, we can't do anything to combine them. We're stuck. That's your answer, okay? Now, these are all log-based 3, so we can condense them. So let's look at E. So all of the positive things, so that would be this one and this one, will multiply in the top of our fraction. They'll go in the numerator. All of the things we are subtracting will go in the bottom of our fraction. And then 9 times 4 is 36. Divide that by 6. 36 divided by 6 is 6. Now, 6 does have a 3 hiding in there, but it's not super helpful for us to do anything with it at this time because it isn't a perfect power of 3. So I would just leave it. There will come a time where we'll do something with that, but for now, just leave it. F, the log base 7s are matching. So that's the first step we need for us to proceed. But does anybody see what's wrong with F? Yes. There's a negative. We cannot input something into that. So although D, we just couldn't simplify, it's just done already. E is a no solution. There is no number that we can make that happen. It just doesn't work. It just doesn't work. Okay? So now let's talk about 10. 10 says to solve each of the following for x. Now, for part A, if I look at something that's in logarithmic form and they want me to solve it, I'm always going to put it in exponential form as my first step to see what the heck is there. Our base is 5, our power is 3. That has to equal what's inside. Let me say that again. Our base is 5, our power is 3. It has to equal what's inside. Now, if you told me to solve that equation, it is just an x squared type equation that needs solved. It's really 30x squared equals 125. X squared equals 125 divided by 30. Is it 5 times 5 times 5, 125? Yeah, okay. Both 125 and 30 are divisible by 5, so let's simplify that down as much as possible. That's 25 over 6. And so x would be plus or minus the square root of 25 over 6. Now, yes, we should probably rationalize and make that prettier, but that's not my concern at this point. Let's just leave it, okay? If you were trying to solve that in iMath, probably you wanted to put the positive square root of 25 over 6 in parentheses, comma, the negative square root of 25 over 6. Put that whole thing, make sure the whole fraction is in your square root. Let's take a look at this one. In B, we don't see our base. What's our base? If it just says log, if we don't see our base, what's our base? It's a 10. Let's throw a 10 on there. So we know that 1.5x has to be 10 to a power of 0. Well, anything to a power of 0 is 1, so that's a nice thing to solve. We're just going to divide both sides by 1.5. That's 1 over 1.5. If I see a 0.5 in my denominator, I just double everything to make that fraction prettier. And so my final answer is 2/3. So that's that one. Let's look at C. Now for C, we have to combine these two using our rules of condensing, and addition smushes together and becomes a multiplication first. It has to say the log of something equals something, a number or something like that, so that we have a distinct what's our power, what's our base, what's our number. Our power is 3, our base is 3, our number is 2x squared. Our power is 3, our base is 3, our number is 2x squared. Well, 3 cubed is 27. If I ask you to solve that equation, divide both sides by 2. Take the square root, don't forget your plus or minus on the front. Yeah, we could rationalize and make it prettier. I don't care, okay? So some things to think about. I didn't say this first or earlier. For equations like this, it's not a bad idea. Well, it is part of the process that I should have showed you. We should always check that when we input, we don't get a negative number. If we input a positive, the square is going to keep it a positive. If we input a negative, the square is going to make it a positive. So both of those do work in the original. 2/3 when I plug it in keeps it a positive. Great. Okay. But let's look at the problem with this one. This just says an x. The original version, not our condensed version, but our original version just has an x. When we go to input a negative, it is going to make that one not work. So our answer has to throw out the negative version, and we only get to keep the positive version for that particular problem. So be very careful. If you think you solved it right and iMath yells at you, have you checked it? Maybe one of them works and maybe one of them doesn't, based upon what is there, okay? So that's some equations. Let's take a look at some function-related stuff, and then 5-8 is done. Okay, so I think what they're trying to get you to focus on for number 11 is how our exponential function and our logarithmic function are inverses. So the x's will become y's and the y's will become x's, okay? So you'll notice that it's a base 10. So this one, we're just plugging into that formula, those powers. So 10 to the negative 2 is 1/100th. 10 to the negative 1 is 1/10. 10 to the 0 is 1. 10 to the first is 10. 10 to the second is 100. Do you notice what they put over here? So remember, a logarithmic equation undoes an exponential. So what power did we put on a 0.01 to get, or what power did we use to get 0.01? Negative 2. What power did we use to get 0.1? Negative 1. What power do we use to get 1? 0. What power do we use to get 10? 1. And what power do we use to get 100? 2. See how they took the x became the y's and the y's became the x's. Okay, so you always have to know that relationship as you go through this process. So f is our exponential, g is our logarithmic. So technically, this would become 0.01 and go right back to negative 2 again, because they should undo each other. If we plug in 0 to our f function, we get 1. And what power do we use? 0. Now we're going in part 3, we're going from G to F. So if I get an answer of 1, my number had to be, or I'm sorry, my power had to be. If I input 1 into a logarithm, my power had to be 0. But if I put a power on a 10 of 0, I get back to 1 again. So what this is saying is this one would be 10, this one would be x, this one would be x. Because they're exact inverses of one another, they always reduce down to the original input because you go back and forth. And so that's what they're trying to remind you of for this particular number 11, okay? So our 4-8 investigation is done. Please at this time, turn it in. Okay, so please turn in the 4-8 investigation and then open up worksheet. Well, I guess I did call it number 2, or it's in the number 2 spot. This is the worksheet you want. Okay, we had done the odds together on the front page. So you're ready to do the evens. What I would like to go to is our second page where it says properties of logarithms. So everybody open up the worksheet we started, I think, on Monday, to the second page that says the properties of logarithms. Now, problems at the top up to 12 say to expand, 13 through 24 say to condense. We're going to do the odds together right now, okay? So let's start with number 1. The rules of expansion say if two things are multiplied together inside of a logarithm, that we are allowed to split them up as a sum of individual logarithms. So it would be the log of 6 plus the log of 10. Now, be careful because of order of operations. For number 3, before we deal with the fraction 6 over 11, the 5 needs to multiply down in front, okay? So let's put the 5 down in front. So it's 5 times the log of the fraction 6 over 11. Now, from now on, we're going to ignore that 5. So from now on, let's ignore the 5. Let the 5 continue on, and let's think about what we do about a fraction. In number 1, it was a multiplication. We split it up for addition. For a fraction, we split it up and we subtract its numerator minus denominator. So it's log of the top minus log of the bottom. Now, you could technically multiply through the 5 if you wanted to expand it. 5 times log of 6 minus 5 times log of 11, but I think iMath would probably be okay with you expanding it there. Now in number 5, the 4 is only thing that contains an exponent. So we're going to wait and put that down in front in a second. Okay, so first, just do log of the top minus log of the bottom. Now you'll see that the only thing that has a 4 that can expand further is that first expression. Drop the 4 down now on that first expression. So we don't want to leave any powers in our final answer. All powers should drop down in front. Now let's do number 11. Number 11 requires us to do a rewrite before we try to use the rules from above. Let's rewrite that as the log of x, y, and z to the 1/3 power. Remember, square root can be written as a 1/2 power. A cube root can be written as a 1/3 power. Let's drop the 1/3 down in front, and then let's expand that multiplication. Multiplication expands to do the log of the first plus the log of the second plus the log of the third. Now, technically, you could distribute that 1/3 to each piece. You could have also put the 1/3 on each of those and then dropped it down in front. They're both equivalent. I don't think it matters one way or another. Does everybody see the rules, how we expand those things? Okay, so starting with number 13, we are going to now go back the opposite way. So now think of order of operations in a sense. We're going to mush them back together. So this first one is a very easy one. If you have two logarithms with the same base that is being subtracted, make it a fraction. So that is the log of 3/8. So you can condense it down into one logarithm by making it top over bottom. Now, here's the problem with 21. If there is a number sitting in front, that is representing a power. Let's put it back on. So first, we're going to make that the log base 4 of u minus the log base 4 of v to the 6th. Then form your fraction. So our fraction now can be formed as the top was a u, the bottom is a v to the 6th. Only because the v was the only thing that had a 6 on it, you got to put the power back on before you form any multiplications or divisions. So 23, what's the first thing we've got to do? For 23, what do we have to do first off? What do you think? What's our first step for 23? Yes. Exactly. We're going to take this 20, put it back where it came from as a power. We're going to take this 5, put it back where it came from, and then we'll mush them together into one logarithm. Okay, so this is going to be the log base 6 of u to the 20 plus the log base 6 of v to the 5th. Now we're allowed to multiply them together and make them into one condensed logarithm. And so we get the log base 6 of the multiplication of u to the 20 and v to the 5th. So you're doing the exact opposite order that we did in problems 1 through 11. You're going to do the exact opposite order in 13 to 23. Okay. So that is a little bit about condensing and expanding. So we have two worksheets we have done. Worksheet number 1, worksheet number 2. We've done half of them together. It's your responsibility to do the other half by Sunday. Okay. You saw how quickly I can do them. I just need you to get some more practice so that you don't go into iMath and go, what in the world are you talking about? Okay. So that is that. Hopefully you have turned in your Mod 4.8. Please at this time open up your iMath. Look at homework 4-8, day 1. Homework 4-8, day 1. I would like to do on question 3 for me. Could you please jump to your question 3 when you're ready? I just want to do with you, well, let's do all of these ones. Let's jump to question 3. Let's go to A. So our original equation is y equals 7 to the x. So we know that x equals the log base 7 of y. Okay. So they want this time you to type in the entire thing. But the one I'm really concerned about is B and C. Now, again, adjust it. Your numbers and my numbers are probably different. Here's my problem with this particular number, question 3B, please. Let's look at what's wrong with that, or what's causing issues. See this number on mine here, this 6? That 6 is causing an issue. You have to divide off the 6 first. So you get v over 6 equals 1.7 to the t before you turn it into logarithmic equation. Okay, so our base is 1.7, our power is t. So t is the log base 1.7 of the fraction v over 6. Okay. And then C, there's some issues as well. So let's deal with the issues for there. Well, there's not as many issues, but I think there's some. So let me show you. Our base is 3, our power is 8a. So the log base 3 of b should equal 8a. Now I think we can just write it like that, but if iMath argues with us, we may have to divide both sides by 8. Okay, so I'm going to put it in like that first, and then I'm going to see if iMath messes with it. It might not like it. We might have to divide off the a, but let's see if iMath is okay leaving the 8 there. But technically, you could have divided both sides by 8 if you needed to know what a is. Okay, so that's homework for 8 day 1. And of course, that's your responsibility to finish. At this time, I want to look at homework 4-8 day 2. Okay, so go into homework 4-8 day 2 questions. I have to press a million things to get there, but okay, it looks like this. Homework 4-8 day 2 looks like this. The first thing they want us to do, this is why I wanted you to practice it, is to condense A, B, and C, okay? So let's go ahead and condense these things. Now, part A, all of those things, you'll see how all of those are added up. So we can condense them if we just do 6.75 times 80 times 20. And it doesn't say to do the math, so I am going to do log underscore 5, and then in parentheses, I'm just going to let iMath do the work. I don't know. I'm just going to see if they'll accept. Do they? 6.75 times 80 times 20. Okay. And then this one, there's a few different things I'm going to show you. Okay. B, that is the log base 4 of 1/6 times 1/24. That's one logarithm. I think they're going to be okay with that. So let me kind of submit that for a second. And then let's look at the last one. Now, my last one and your last one might be different, but they probably have a common theme. Do you see how my C has a 2 in front? We have to make that a power first. So that would be the log base 6 of 9 squared times 12, because that 2 would go down the 9 and make it a 9 squared, but the plus makes the 9 squared and the 12 multiply together. So I think that's what we have to put, the log base 6 of 9 squared times 12. Because the 2 has to become a square before we condense it together. Okay. So that is homework for 8-day 2. Yes.
So what if for C, going back to that, what if the numbers instead, like the number of was 3, but the two numbers inside the logs were 13 and 2, so would it be 13 to the third power?
Exactly. Yep, you got it. Okay.
I'm just making sure.
Nope. You got the idea. Yes. Let me see. So there is question number 1 from the 4-8 day 2. Let's see. Oh, put that all in its own parenthesis. There you go. Because you want it to show that's the stuff inside that logarithm. A good point, guys. You might notice a little hint for everybody. You might notice that I put everything that is supposed to be in the logarithm in one set of parentheses. So if you use multiple parentheses, you can do that, but you need one outer parenthesis that should make it work. Okay. So now let's jump. Let me see what's different. So here's what's different about question 2. See how the words say use a single logarithm and simplify, okay? The last ones, I didn't simplify them. So I would like to do this one. I'll show you mine. Yours and mine might be a little different. So this would be, mine would be, question 2, the log of 125 to the 1/3 minus the log of 64 to the 1/2. This means take the cube root of 125. It is a doable thing. That's just the cube root of 125. For me, might be different for you. The cube root of 125 is 5. This really means the square root of 64, which is a doable thing. The square root of 64 is 8. Oh, I should write that. I'm sorry. So that would be the log of 8. And so our final answer, condensed to one logarithm and simplified, is the log of 5/8. Now, if that fraction 5/8 is simplifiable, please simplify it. My fraction 5/8 is not simplifiable. You can't reduce it, so leave it. Okay, so that is my answer for question number 2. Okay, so that's question 2. Let me just check to see what other ones we got here. Oh gosh, that's so tiny. How do you read that? Rewrite the following expression as a single logarithm. Okay. Now, mine and yours might be different. Oh, it says explain your reasoning. That's wonderful. Okay, so I'm going to write mine out bigger. Again, please adjust if yours is a little different. And if we have time tomorrow, we'll do a few more things. Okay, So the first thing I would do is I am going to distribute this -2 to both pieces. So I'm going to get the log of x minus 2 times the log of y minus 6 times the log of z. Now, the numerical components that are sitting in front, don't worry about the negatives, but the 2 and the 6, let's put them inside and make them powers. So that would be the logs of y squared minus the log of z to the 6th. Now, anything that are positive are going to multiply and go in our numerator. Any pieces that are negative are going to multiply and go in our denominator. So the negative pieces are going to go in our denominator, the last two, and the only thing in our numerator is an x. So now we get to condense it. The x is the only thing on top. We have a y squared times a z to the 6th on the bottom. So the log of x divided by y squared z to the 6th. Okay, wait. Let's put the y squared and the z to the 6th in parentheses. So it knows each piece goes on the bottom. Yeah, I think it looks the way I want it to. See how I put that whole fraction in parentheses? And then what's your reasoning? Just kind of go through the steps that are on that page. I distributed the -2. All positives go in the numerator, and all negatives in the denominator. I don't know, you could probably say more than that. I use the rules of condensing. There you go. Okay, so that is question 3. We're going to kind of stop for now, timing's sake. Tomorrow we're going to talk about 4-9, which is just equations. So it's just applying some of these rules we learned today. Remember, you should probably be working on some homework. You do have Friday, Saturday, and Sunday to work on those things. Everything is due on Sunday. Grades are done. If you need anything, if I missed anything, if anything is wrong, I need to know it now. Let me know. I think I got them pretty close to being correct, and everything should be pretty darn close. Okay, so there you go. Hopefully that helps you get through the 4-8.